Hi. Hi, Yaneer. What's up?
Hi, how are you?
So what are we going to talk about today?
So I understand that you've been thinking about this new study about masks and its implications for
But
the
the,
outbreak.
the study is bad, the interpretation is worse. But by the way, congrats on your new setting that has books in the background. I'm Sefarim.
Thank you. Thank you. That's, I think it's, well, it's a, I think it, it's a nice background and it's got lots of good books.
Yeah, but you have books that people don't read, like these collection of, you know immediately if books are read or not. Very similar hardcover. Uh,
Actually, that's the Great Books series.
yeah, exactly. So when people buy book
You use the
series,
reference, you pull it out. I actually look at it from time to
no, but
time.
it's monoculture. You buy book series or Nobel Prizes, stuff like that. This book series, someone has decided on a choice for you. No, 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 it's not good. Anyway, so let's talk about the study, that Dutch study. Okay.
Yeah,
So what's
go
your,
ahead.
no, you start.
You want me to start? Okay, so first of all, the study as it's written is pretty clear about its own limitations and what its conclusions are. The problem seems to be that there are people who claim either to be scientists or just, out there talking about stuff and don't seem to know science, whether or not they claim to be scientists or not. So there has been a whole bunch of claims that this study shows that there is no significance to the use of masks. And the study itself is very, very clear that that's not what it says.
Exactly. No, they are okay. So let's describe the study. Let me describe this.
Now, wait, there are also some issues with the study and what we can learn from the study. But even then, the study is pretty clear about most of those issues in a scientific way. They explain what you can learn from this study and what you can't learn from this study. But it seems that some of the people who are claiming that this study shows what it doesn't show are just ignoring what the study itself says, which is pretty clear in that regard.
So
But go ahead, why don't you take
we're
it from
not
there?
disagree, but let me describe the study. All right. Uh, I read the studies several times, as you did, and then I listened to an interview by the lead author, Bundgaard. I don't know if I'm mispronouncing the name, who's a cardiologist, and who he said, "I'm doing what we do in cardiology to test drug effectiveness. Well, basically, you select a cohort. In this case, it was not blind, but you have X number of people take the drug, X number of people don't take the drug, they take a placebo or something, and you compare, okay? And then you can see the effectiveness of the drug, you can see the side of it, you can get information. So he thought it was as simple as that, it was masks, and said, okay, this incrementally, what is the incremental benefit of adding two regular measures, the face covering, masks? So he gave, it was not, of course, blind study because you can't have a placebo
Whether
mask.
you're wearing a mask, you're not wearing a mask, you know whether you're wearing it or not,
I mean,
yes.
to invent this placebo mask could be interesting. And then he gave the masks to about, I don't know, it started off close to 3,000, ended up, as we see here in numbers, about 2,400 or so. And then a crowd didn't have the mask. And then they tested you at the end or in whenever you got sick, okay, whatever comes first. And then they discovered that either, they say how many people had either COVID or antigens or antibodies, sorry, showing they had COVID, okay, in the study. So that looks like an interesting, way to do things. And their discovery was about 2.1% in the control group had COVID versus 1.8%.
About 50 something, 50 few
Yeah,
cases.
so something like that. Okay, so the which is 42 out of 2392 or 53 out of 24/7. Okay,
Right,
so
so the first thing to say is that the 42, which is the lower number, and the lower percentage is for the people that wore masks.
Yeah, no, that's the thing is it's going to be even more interesting. Now, in the study,
But let's just start by saying that.
one thing. Let's start with one thing. All right, is that let's start with one that one thing that they reveal in the study when they tell you, oh, this is how we test people. They're doing either PCRs. Of the PCR cohort, 0 wore mask and 5 didn't have masks. And then you have the antigen. The antigen have a 90% sensitivity, sorry, 90% specificity and something around 99% sensitivity, 99. So, which means that, okay, and let me tell you, there's something that needs to be taken into account. That you have X1, this one, X, and people who are really infected in your cohort, okay, infected but sick, plus you have a certain number, okay, positive but not sick, okay, somewhere between 20 and 40, okay, and then you have a certain number of people sick but not detected, and for a total of, say, between 2,400 and 2,500, okay? So each cohort, when they looked at the power of the study to try to derive how much they need, what sample size they need to get their p statistics correctly computed and have enough power for the study, okay? They picked a 2% base rate, you know, okay, 2%. They did not take into account that you have additional variance coming from these two. Okay?
Yep.
So if you have a false positive rate between 1 and 2%, okay, then you need much, much larger population because the variance is much higher. So
because if you bottom line, if you take 1% of their of the number of people,
that's 25
you
people.
end up with about half of the number of cases that they got.
Exactly, correct. So you need, in other words, if you have twice the variance, you need 4 times the number of the N to be the number of people in the experiment to be. Okay, so in other words, he's to reach whatever conclusions he claims to have, he needs 4 times the amount.
Right.
All right. That's
so, but let's start with the more basic things, maybe.
There is another problem. This is methodological flaw, because this is cardiology where you know if the person died or didn't die, okay?
Right.
Blood pressure did this or didn't do that. It is a test that has a high false positive rate, geared to false, you know, and then a high false negative rate. Okay, I mean non-zero false negative rate. Okay.
Yeah.
So you have a problem that because you're dealing with 2% infection rate in the population, the small probability, okay, gets swamped by the noise around the test.
Right.
That juts out immediately, but that's not what irritated me about it. Mm-hmm. The second point is that of these people infected, how many were infected at home? Okay.
Right.
Okay? So you have to compute.
They don't know that.
Sorry?
They don't know that.
We don't know how many are infected at home, but the number of people infected at home, okay, needs to be deducted from that number when you do the odds ratio.
Right, or anyone that was infected by other means except for by respiration, right? So there's some rate at which infection's happening not by respiration, right?
Exactly. So that's the flaw. The flaw is that people have the impression that the study is telling you, okay, that masks are not effective, you know, to control the disease, when in fact that's not what the study claims. Okay, to get
but first,
you need to discount the number who get it at home.
Absolutely. But let's go back to basics so we can explain it a little bit simpler. Okay. If you draw a line between 0 and 100% in terms of effectiveness of a mask,
Yes.
just draw a line segment between 0 and 100% of the effectiveness of a mask. Just a line segment, 0 and 100%. 100% over there and 0 over there.
Yes.
Their results, the results that they say are, and they're very clear about this in their conclusions, they say there is a range between 46% reduction, meaning an effectiveness of 46%,
So this
down to, let's say, let's just say 0, because it can't be greater than 0, but in principle, it's also could be negative. So
yes.
mask could cause you to be affected, right? But that's the range.
Yeah, no, this actually has other
range. The middle of that range is about 20%. What?
Okay, there's
about
actually
10%.
and the way they compute it is that their odds ratio they give you is 82%, which is basically the odds ratio is, you know, 20% effective, 18% here. That's what they got, the odds ratio, and then they do a confidence interval between 54.54 and 1.23. 1.23, which is another problem because, as you're saying, this cannot be negative. Okay, so
right, but
there's a way.
But let's just put.
Hold on. There's a way to compute odds ratio. You have to understand what odds ratio mean, and effectively, if you compute the odds ratio properly, okay, that this is much lower. Precisely, I mean, if you look at the effectiveness of mass, because you have to confine. To compute the odds ratio, you have to confine it to the source, to having the source of risk being equally, not only exhaustively shared by both parties.
Right, but I just want to point out, I just want to point out that their study, even the way they originally stated, and they're very clear about this, is consistent with over a 40% effectiveness of masks.
And more, because if you're
right.
not. Because
but the point is that every time
being outside, the point is you have, if you stated conditional probability, conditional on being outside, how much would a mask be in effectiveness? Okay, therefore you have to compute the odds ratio by deducing the infections that happen at home.
Correct.
Okay,
so but I'm trying to build it up. I mean, you're trying to go to the second step. I'm just trying to do the first step.
More than you know, the gains got to be a lot more than 18% in expectation, and also this cannot go negative. You don't have a Gaussian distribution. The other problem, of course, the distribution no longer Gaussian.
Totally. The point is the following: if you have a range that the study says is the range, and someone else tells you there's this very basic fallacy that people constantly make in all kinds of things, but shows that people don't understand math and science, is they confuse statistical significance with significance.
That's another.
You can find an effect which is significant and it's not statistically significant, and you can find something that's statistically significant that's not significant. It doesn't matter. In this case, and the effect that they found is significant. And what people are then interpreting it as saying that, oh, this is not significant because it's not statistically significant, which is wrong. So anybody that claims that is simply freshman statistics, they don't understand.
Yeah, no, this is effectively, no, there's something, a flaw with this paper. In addition of all of that, is that.
No, but wait, that's not a flaw of the paper. That's a flaw of the people who are claiming to interpret the paper.
No, the flaw of the paper. There is a flaw in the paper. The flaw.
Yes.
I mean, there is a problem with the paper, not a flaw. They have flaws. The flaws, what I showed you, computing odds ratio, because it's conditional, unconditional odds ratio versus conditional odds ratio, since you have to compare outside to outside, not person to person. The other, but there's another problem. When you show up with a p-value of 0.33, okay, their best p-value is 0.21. You don't publish a paper on 0.33. What do? It tells you what that p ratio is not telling you anything about the significance of the effect. The significance of the study itself, okay, isn't quite. What do you do then? Let's say I am running a medical journal. I get that paper. I see 0.33. I send it back to him. okay, by telling them, listen, you guys are nice guys, but go and increase your sample size.
Exactly.
That,
But the point is that there are different, this goes back to which question you're asking. One question is, do you know that the effective mass is not zero? That becomes what some people call statistical significance. Another one is, do you know that the effect is not 100%? Is it less than 100%? And that's a different question. And so
this is all right, but I'm saying without going very, very far, okay, they, according to their own calculation, did not have enough of a sample to make a claim.
that's correct. But when you add to that these other issues,
okay, the other issues, they basically there's no paper. So when we
there's no paper. Exactly.
This is
that's
not
right.
What is interesting to me, it just hit me, because I was talking to some friends who that nobody in that field thought of integrating this variance. Okay, simply because when you buy these statistical packages, that, you know, they don't know how these metrics were derived.
Correct.
What I call fortune cookie, sometimes cookbook, generously, but more accurately fortune cookie. The verbalism, or this is our thing. So the fellow is a cardiologist, okay? So this ain't cardiology, okay? This is something where we have an error in the measurement. And also there are other things like this ratio of infection at home that was a dominant source of risk, you see. And also then realize that in cardiology, where the sources of risk, all right, are usually within the study, not external to the study. So
let me summarize it in the way I would explain it. If you look at the study itself, even if it's articulated, the study itself is consistent with a significant effect of masks. If you look at the underlying issues, there are several issues, including the quality of the test, right? The false positives in particular, and the fact that people can be infected at home, not just in the place where they're trying to test it, because they didn't wear masks at home. They were specifically not told, you know, that they didn't have to wear masks at home. And we know that transmission at home is a factor, even though they claim that it might not be an effect because of some information, which, by the way, undermines the whole study, because it says that there's no coupling between people who are sick at home, which suggests that the fact that there are false positives is a major part of what's going on. But all of these different pieces says that their error range is actually very large. And because their error range is much larger than they report, mathematically we can correct for it. We realize that the entire data that they have is consistent with any hypothesis that you would come up with. It's consistent with masks being 100% effective. It's consistent with masks being 0 effective. And basically, it doesn't tell us anything about what masks are about.
Yeah,
that doesn't mean that masks are not effective or are 100% effective. It just means that the study doesn't help us figure out what was going on.
The only, as I said in my tweet and in the article, the only information we're getting from that is that they don't know how to conduct a study. Okay, that's it.
Well, I mean, they know how to conduct a study, but they didn't have a powered enough study. They can talk about it over lunch with someone, but they really shouldn't be published.
No, they shouldn't be doing studies without understanding the statistical effect.
The statistical effect.
The whole point is that medicine is, when you talk evidence-based, and then there's a schmuck who wrote about it in some paper, who didn't even understand it. It was professor evidence-based. We know what problem.
That's right. Anybody who claims that they are a scientist who doesn't understand the difference between statistical significance and significance, and doesn't understand that different hypotheses have to be tested by different data, is just not a scientist as far as I'm concerned. He's just.
I don't know. You have a rosy view of science. I don't view scientists as authoritative, as the science as an authority, because of the scale transformation. Anyway, so great. Do we have anything to add about the study? I have a paper.
No, I just think that I really think people need to go back to understanding that science is something that has to be done carefully.
Exactly. And
you're in a pandemic, if you make claims that are false, you should be held accountable for your claims, and for the fact that people will do things that are harmful to themselves based upon your claims. Nobody should be making casual statements that are without careful understanding, and anybody who makes such claims should be really dismissed. And this is important in this context, and we know that it's important in this context. And these people who are making claims about this study to say that people shouldn't wear masks, which is totally not what the study would say, even if what people are claiming about this study, because there's no doubt that one of the things that this study never had in mind is the effect of people wearing masks, because it only studied the effect of a few people wearing masks in a population that didn't wear masks.
Okay,
so it doesn't include a combination of multiple people wearing masks and protecting each other from wearing masks.
One more detail before we finish here, the central. You know, as I said in the beginning, we had 5 people who were infected by PCR, and PCR doesn't have a real false positive, false negative, except if the someone is drunk or mistook the name of someone else. Yeah. Okay, so you have 5 for non-masks, for 0 for masks, and to me that's the only information that's reliable. So
interesting. Yeah,
you have 5.
All the rest is the
model. If you ignore the rest, exactly. If you ignore the antigen, stuff like that, because you say it's too polluted, because 2 small probabilities versus 2 small probabilities. If you just did the 0 to 5, okay, just if you look
have
at
the right, you have an answer that actually makes some sense. Yeah.
Okay, go get a mask. Okay, go get a mask.
Right.
One, yeah, go get one quickly. Okay.
Absolutely.
Arrivederci. Tov meod. Okay. Okay. Very good.
Take care.
Bye, everyone.
Bye.
Thanks.